Okay guys, let's start with our second normal form. See, if we have seen our first normal form, it uses two things. One is the table must be atomic, and the second one is it shouldn't have multi-valued attributes or composite attributes. Similarly, coming to the second normal form, it also had certain things, certain constraints to be satisfied. First of all, it should be in the first normal form. Obviously, almost all the tables whichever are being stored into the database will always be in first normal form. But for any second normal form, first of all, it should be in first normal form. As well, it shouldn't have any partial dependency. It shouldn't have partial dependency. So if at all, if a table has to be in second normal form, first thing, it should first satisfy the first normal form. Second thing is it shouldn't have partial dependency. So what are the rules for what is partial dependency? First of all, we should know what is partial dependency, and how we can say that there is no partial dependency in a table such that it attains or it is in second normal form. Okay, so if at all, if you wanted to know the definition for partial dependency, it is something like this. If there is x determines a, if there is a relation like this, x determines a, always remember this is a capital letter X and this is small letter a. Okay, it means that this X can be can consist of multiple attributes, whereas coming to a is a single attribute. Okay, if suppose if there is a multiple attribute even on the right hand side, then what we can do, by using decomposition rule, we can convert it into two different FDs, functional dependencies, yes or no. So instead of doing all such things, we are defining a rule for partial dependency like this. How? If capital X is nothing but a group of attributes, determines a small a, that nothing but determines a single attribute, in that case X should be a proper subset of some candidate key. This is very important. X should be a proper subset of candidate key, and A is a non-prime or non-key attributes. See, there are many things here to know. In order to understand second normal form, we should know what is partial dependency. In that, we should know what is candidate key and what is primary, prime key, non-prime and prime attributes, or key and non-key attributes. Okay, so what is candidate key? As we have seen earlier, if you wanted to know about the candidate key for a given functional dependency, we will be first identifying the essential attributes. Yes, we will be first identifying the essential attributes. So what is this? See, look at this particular example. R of A comma B comma C comma D is the relation, is the table which we have. R is a relation now, R is a table. So this particular table is having four attributes A, B, C, D. From these four attributes, we are able to attain some different things, something like this, FD rules. These are said to be the FD rules, functional dependency rules. What it determines? A determines B and C determines D. This is what is the characteristic of this particular relation R of A, B, C, D. Okay, now we are in a process to identify prime attributes as well as candidate keys, all these things. Okay, so in order to identify candidate key, we should know what is the essential attributes here. Yes, yes. Now what is an essential attribute? An attribute which cannot be attained by some other attributes are said to be essential attributes. So once we find such essential attributes, we'll be applying the closure for those essential attributes and identify whether we are able to reach all the tables, all the attributes in the table or not. Yes, so what happens here? I have A is able to determine B. Similarly, I have C is able to determine D. These are the things which are determined. So, but this particular table consists of A, B, C, D. If you look at these four columns, these four attributes are not attained by any other attributes. Only two are able to be attained. That is, B is attained from A and D is attained from C. That means A and C are not being attained by using various FT rules. As a result, in order to identify the candidate key, we will identify the essential attributes. As a result, from the given functional dependency rules, we can come to a conclusion that A and C are essential attributes. Only from this we are able to attain other things, and these two things, A and C, are not being attained by some other attributes. So the main essential attributes for this particular relation is A and C. So by using AC, are we able to attain all the other attributes of the relation? For that, you should know what is the closure of AC. So when identifying the closure, you'll be writing it as AC plus. From A, you will reach to B, as well from C, you'll reach to D. This is what is happening here. That means AC, when we consider it as an essential attribute, from this essential attribute, we are able to attain all other attributes. As a result, I can say that AC is a candidate key. Similarly, A comma C are prime attributes. Essential attributes are nothing but prime attributes or key attributes. Similarly, non-prime or non-key attributes, which are not essential attributes, are simply called as non-prime or non-key attributes. Those are nothing but B comma D. Okay, so now this is being attained. What are we saying? X, when for partial dependency, X determines A, where X is a proper subset of some candidate key. What is that? A comma C. Is it a proper subset of candidate key? Yes. A alone is a proper subset of candidate key. C alone is also a proper subset of candidate key. As well, A, small a. A is non-prime. What is small a here? That is B and D. It should be a non-prime or non-key attribute. Is it a non-prime or non-key attribute? Yes, because these are not in the essential attributes list. These are not in the list of essential attributes. Is this clear? So we will say that this particular relation, the relation whichever is given here, is having partial dependency. But for 2NF, what is the condition? It should not have partial dependency. It should not have partial dependency. First condition is it should be in first normal form. When you consider this, identify whether this is in first normal form or not. For first normal form, for a table to be in first normal form, it should not have multi-valued attributes or composite attributes. Yes, the same thing is happening here. There are no multi-valued attributes or composite attributes. So the first condition is satisfied. But we also have one more condition, that is it should not have partial dependency. The relation which we checked here, as soon as we identify this, this is satisfying the rule of partial dependency. As a result, we will say that this particular relation is having partial dependency, and hence this is not in 2NF. Is this clear? So let us see one more example regarding this. It is not in partial dependency. What to do when a table is not in partial dependency? What to do when a table is not in partial dependency? Okay, so let us take this particular table: customer ID, store ID, and purchase location. If you can look here, you have many things: customer ID 1113 Los Angeles. See, if you can remember, look at this. By looking at this, can you tell this is in first normal form or not? Yes, of course, because this is not having multi-valued attributes. This is not having composite attributes. As well, this is also having a unique value. How are you saying that it is having unique value? By saying that 1 1 and Los Angeles, 1 1 and Los Angeles. That means this particular row alone is unique when compared to all other rows, and hence we say that it is in first normal form. Now we wanted to check whether it is in second normal form or not. Now we wanted to check whether it is in second normal form or not. For that, you see here, what do we want here? We need to know the table should not have partial dependency. What is partial dependency? X determines A. When we say X determines A, X is a proper subset of some candidate key, and A is non-prime or non-key attribute. Yes. Yes, now we should see that. From this, we'll be identifying that, see, primary keys are customer ID and store ID. So X determines A. The non-key attribute is purchase location. The non-key attribute here is purchase location. So this particular table is not in 2NF because it is satisfying partial dependency factor. As a result, we should convert that particular table into 2NF. How to do that? We will be dividing the table into two other tables. That is nothing but customer ID, store ID as one table. That means customer ID determines store ID alone and store ID determines purchase location alone. As such, we'll be getting two different tables. Now, each of this is in second normal form. Is this clear? This is what is second normal form. Only two conditions, that is, one should be it should be in first normal form, and the second should be it should not have partial dependency. Okay, so in order to make, if suppose if at all if you find some table is staying in partial dependency, it means that it should be divided. It means that when it is not have, if it is having partial dependency, it means that it is not in second normal form. So to convert it into second normal form, you should divide the table into two parts like this, determining the same one attribute determines the other attribute. Is this clear? Coming to the third normal form. So when you come to third normal form, you have as such the same as you'll have certain constraints here. One thing is, as we are discussing with third normal form, obviously, first of all, it should satisfy that particular table should satisfy second normal form. So first of all, it should be in the second normal form and it should not have transitive dependency. It should not have transitive dependency. What is transitive dependency? Transitive dependency is something like this. See, A determines B and then B determines C. Then we say that C determines A via B. Okay, that is called as transitive dependency. So, if you look at the example here, the given things are book ID determines genre ID and the genre ID determines genre type. Okay, that means book ID determines genre type. Okay, via genre ID. So, this is what is happening in the third normal form. So, what it should have? There should be no transitive dependency. Third normal form doesn't accept transitive dependency. It shouldn't have transitive dependency, but here we are able to get transitive dependency. Yes, so for that, when we say that there is transitive dependency for a table, it means that the table is not in third normal form. So to convert the table into third normal form, again it must be divided into various tables. Whichever is violating, whichever attribute or whichever column, otherwise whichever column is violating the rule of third normal form, that you push it aside. So when I'm saying in our earlier example, I mean in our earlier, whichever is not in third normal, in this particular table you had book ID, genre ID, genre type all in the same table. This book ID determines genre ID determines genre type. Okay, which means that book ID is determining genotype. So now this, because of this genotype, we are able to violate the normal form, but we need the table to be in third normal form. As a result, what you'll do is book ID, genre ID and price, and genre ID alone will determine genotype. See, if you look here, book ID, genre ID, this is one table. This particular relation alone, this particular FD rule will be alone, one comes under one table and this particular rule comes under another table. Okay, this is how you should remember. This is how you should remember, because of the usage of these two things in the same table, you are getting transitive dependency, which is not acceptable. As a result, what you should do is you should divide that particular table into two other tables. How that is done? That is done in this way, like book ID, genre ID, and price is one more column here. This price can be even available here or it can be available here. There is no, it is just given in the table, but we don't have any information regarding this price here, so it can be provided in any of the tables, no issues. Okay, so book ID, general ID, and price I'm putting it one table, and general ID, genotype as a separate table. Now the names of the tables also will be changed: table book and table general. Earlier it is table book detail. Now it is converted into two tables, such that it is having, or the table is in third normal form. Now if you consider, or if you check for these two things, you will not attain any transitive dependency. As a result, this is said to be in third normal form. Is this clear? This is what is second normal form and third normal form in our session.